Hello, ladies and gentlemen. Welcome back to Chapter 20, where we have been talking about mixtures. And this is Mixtures Part 5. Okay, we have talked about solutions. And what you can see first is what is called an unsaturated solution. This is a solution that can have more solute dissolved in it. Remember, solute is the stuff that gets dissolved. And if it is saturated, that means that there is as much as can be dissolved is dissolved. Okay, so this is just a way of talking about solutions. Either you can dissolve more into it or you can't. And that's be the saturated. Okay? Now, when we're talking about this, what you'll see at the saturated solution is you see this little part right here that says dissolving and recrystallizing. This is what is known as dynamic equilibrium. It means that there's just as much dissolving as there is recrystallizing, so you always have the same amount dissolved. It's dynamic as in it's moving, but it's still at equilibrium. It's not changing overall. Okay, when we're talking about solutions, one of the terms we need to talk about is solubility, which basically just means how well the solute can be dissolved. And again, remember the solute is what gets dissolved, the solvent is what is doing the dissolving, and if you're not sure which is which, you go by whichever has the largest volume. So like if you're mixing two gases together, whichever one there is more of, that is the one that is considered the solvent. Now, today primarily we're going to talk about solubility, and we're going to talk about things that affect solubility. What'll speed it up, what'll slow it down, how well can that solute dissolve. And we're going to talk about the differences between solids, liquids, and gases with these solubility things and how well they mix in the solutions. Okay, so first we're going to talk about solids and liquids with temperature. Now remember, temperature is not how hot or cold something is. That is heat. Temperature is a movement of how fast molecules are moving. Okay? Now, with solids and liquids, as you probably know, if you increase the temperature, it increases the solubility. So whether you are heating it up and making the molecules go faster, or whether you are stirring it and making it go faster, you are going to dissolve the solute faster. Just like if you have sugar and you want to put it in tea, it dissolves much better in hot tea than it does in cold. And that's simply because the molecules of the solute are interacting with the the molecules of the solute and the solvent are interacting more often because they're going at a faster speed. So you're going to see it dissolve quickly. Okay? Whether you're talking about stirring or heating it up, as long as the molecules are going at a faster speed, you're going to increase the solubility. Okay, now gases work a bit different. If you increase the temperature for gases, they're going to be going faster, but it actually decreases their solubility. This you want to think of if you have something like a soda can or a soda, and you have it in a cup and you put it on a table on a nice hot summer day. All of the carbonation leaves and you end up with warm, flat soda. Okay, that is because as you heat up the gas gets going fast enough that it actually will leave the solvent. And what ends up happening is all you're left with is the solvent. Okay, all of the gases will leave, and you'll end up with the gases gone. All you'd have is the solvent left, and you'd have flat soda. Okay, so keep your soda chilled if you want it not to go flat. If you like flat soda, go warm it up and then cool it off, and all the bubbles will be gone. There are those people. Okay, but it's an opposite effect. If you heat it up for solids and liquids, the solubility is increased. You heat it up for you increase the temperature for gases, the solubility decreases. Okay? Now, when talking about pressure, pushing on it, when you're talking about solids or liquids, pressure has almost no effect. And the question would be why? Now, you need to think about what you know about solids and liquids, what they are, what their atoms are like. A solid has atoms and molecules packed closely together. One of the descriptions of a solid is it has very low compressibility. It's hard to put pressure on it. A liquid also has atoms and molecules that are close together. Not quite as close as a solid, but still very close together. It's hard to compress a liquid, just in the same way that it's hard to compress a solid. That's why hydraulics works. Remember, you compress a liquid, it causes mechanical stuff to happen. So the reality is because solids and liquids are hard to compress, because the atoms are already so close together, pressure basically has no effect on how well they dissolve, because they're not affected by that pressure. Now, very different story when we're talking about gases. For gases, increased pressure causes increased solubility. If you look at the picture on the left, okay, you have this gas, it's kind of dissolved in the liquid over here. You can see normal conditions. However, when you compress it, gases are easily compressed. And what happens is it pushes the gas down into the solvent. So you actually end up with more gas dissolved in a high pressure situation. And that is exactly how the carbon dioxide is pressurized into your soda and kept there, is because your soda is under high pressure, which is of course why it has the warning on the outside that says, warning, contents under high pressure. Turn away from your face before you open the cap. Okay? Because it actually is under high pressure. Now, the moment you open that top, you hear that psst. That is the release of the pressure. And all of a sudden, all of those gas bubbles start bubbling up to the surface. You have decreased the solubility of the carbon dioxide in your soda. So all of the carbon dioxide will start leaving the solution, your soda. And you'll see those bubbles rising to the top. And there will be a lot that stays in the soda, but it will be much less than it was before the pressure was released. Okay? And by the way, that psh sound and all those bubbles coming up to the top and causing the almost like a foam on the top is called effervescence. You may have heard it in a commercial or something. But that release of the gas out of a liquid is effervescence. Okay, we will talk more about mixtures next time. And until then,